Put the following equation into the form f of x equals a parentheses x minus h parentheses squared plus k. And we have f of x equals 6x squared minus 12x plus 8. This is general form for a quadratic function, and they're asking us to put it into standard form, or the vertex standard form of a quadratic function. This can be done in two ways. First, I'll show you the basic approach, then I'll show you a potentially much nicer way for you. The basic approach is complete the square. Now it's a little more confusing than perhaps you've seen it before, because I want to leave all the work on the right side. I don't really want to mess up f of x. Okay, the 6 in front of the x squared can't be there to complete the square. So I start by factoring out the 6 out of just the first two terms, leaving x squared minus 2x. Okay, now if I take the negative 2 and I divide by 2 and square it, I get 1, which means I have to have a plus 1 to make a perfect square. But mind you, it might look like a plus 1. It's in fact times the 6. I have now added 6 by putting a plus 1 in the parenthesis. I have added 6 to the right side of this equation. Now I could add 6 to the left side, but I'm not going to mess up the f of x. So instead, adding 6 to the right side and subtracting 6 from the right side keeps this in balance. I now have f of x equaling 6 times. This is a perfect square trinomial. It is x minus 1 quantity squared. And this reduces to plus 2. F of x. What I've done is I've completed the square, and although work is very simple, it's not necessarily easy. Now the other thing we can do is first notice we have a, because the coefficient in front of the x squared in general form is the same as the coefficient in front of the x quantity squared term in standard form. So we already have that part. And the vertex, we have a way to get the vertex. Now from here, I could get the vertex of 1, 2. But I can get the vertex with the formula approach as well. The opposite of b is 12. And 2a is 12, so I get 1 for the x part. And I plug that into the function. And I got 6 minus 12. Wow. Sorry about that. Six minus 12 plus 8, which is negative 6 plus 8 is 2. Great, so we have the vertex 1 and 2, and we can go backwards knowing the vertex what the standard form should be. The a is 6, and it would have to be x minus 1 quantity squared and plus 2. So for those of you that don't like to complete the square to get a quadratic function in standard form, you have this other option of finding the vertex and moving backwards into the standard form, knowing the a value. Two ways to solve this one problem. I hope this helps.